Welcome to School of Computing. In this session, we will try to discuss the process of converting an infix expression into postfix. So we will implement infix to postfix expression through C programming language. For example, A into B plus C by D is an infix expression. Similarly, another example, 9 plus A into 5 plus b by f. So friends, in expressions we can have variables, or at times we may find numbers also. So before we implement infix to postfix conversion, we need to understand the process. So in our previous discussions we have seen what is a stack. We know how to perform push and pop operations. So we will try to use the same and we try to do this conversion, and we have seen and discussed in detail the conversion process. Now let us try to implement that process using C program. So how do I build my logic? So I may find operands and operators in an expression. So first of all, I should know how to detect whether a given symbol is an operand or not. Operand can consist of what? Operand can be an alphabet, or operand can be a number. So in C language, we have a header file called as ctype.h. In this header file, we have functions like isAlnum. So if you pass any character as input, it will return whether that character is an alphabet or number. So to check whether a given character is alphabet or number, isAlnum function will help us in identifying. So once if it is identified as an alphabet or number, straight away we will push it to our postfix expression. And if it is an operator, what we have to do? We have to apply the precedence norms. So precedence norms means priorities. For example, in C programming, the XOR operation has got the highest priority. Multiplication, division have got the second highest, and most common operators which we find are arithmetic operators. Plus and minus has got the least priority. So in my program, I would like to represent plus as well as minus with a priority of 1. Star and slash will have higher priority, so we try to represent them with 2, and XOR we represent with 3. So in my expression, I'll be scanning my infix expression character by character, and whenever I find a particular operator, I try to assign a priority to it. So based on the priority, I will decide whether to push it in the stack or not. So for example, initially let us say the stack is empty, and if star is an operator found, so since it's an empty, I can directly push star here. Now for example, after star, if I get plus symbol, plus has got least priority than star. So based on that priority number, I can decide whether I can push or not. So plus can't be pushed here because of low priority. Then the star will be popped, then plus will be pushed in place of it. So how do I implement the process? We have seen the process in our previous session. To implement the process, I need to write the logic. So I'm trying to build the logic. So isAlnum function will help me in identifying whether the given operand is either alphabet or number. So to identify an operand, I need alnum function, and for operators I assign priority. So I need multiple functions like push function to push something into the stack, pop function to pop the elements from the top of the stack, and alnum function for checking whether the given character is an operand or not. Precedence is one more function where I give a number to my operators. Precedence, based on the precedence I assign a number. Like that I'll try to build. So I'll be writing push function, pop function is alnum, and I write one infix to postfix conversion function in which I build my output string. So in the last session we have seen the process of building our postfix expression, output expression, by applying that conversion process. So conversion process we know very well, and let us try to apply that conversion process, and let us try to build our postfix expression. So for your convenience, I'll repeat that conversion process again. So what is the process? We have to take an output string. Initially it is empty. We have to take a stack. So I start scanning the infix expression. A, I'll write it as is. Star will be pushed to the stack. Then comes opening parenthesis, then comes B will be written to the output expression, plus will go and sit in the stack. Even though plus has least priority than star, still it can be accommodated in the stack because of the presence of opening parenthesis. After plus I'll find C, so I'll write it here in the output expression. Then comes the closing parenthesis. When you find a closing parenthesis, you pop everything till the opening parenthesis and write it in the output expression. So the current status of the stack is we have only star in it because these two are popped. Then after closing parenthesis I find a slash. You know very well slash can't come and sit on top of the stack because a star which has got equal priority is already present in the top. So star need to be popped. Then slash can be accommodated in the stack. After slash got accommodated in the stack, the next character is D, which is an operand. I'll write it to the output string, and once I reach it to the end of the expression, I will pop everything from the stack and append it to my expression. There is only one symbol slash. I write it here. So this is ABC plus star D slash. So this is the process, and let us observe, let us go through the code, and let us understand how this was actually implemented. So friends, as I mentioned, we take help of ctype.h. Hash define max, you can modify this value. Hash define is a macro which will help me to substitute the value of max with the given number. So I wanted to put the maximum size of my stack as 100. If you want, you can make it 10. It's up to you. Then since I'm writing multiple functions, and in these functions I'm using my stack, I'm operating on my stack, so I want my stack and top of the stack to be global variables such that they can be shared across functions. And since I am representing an infix expression as input, the stack should be a character array, it can't be a number. So that's the reason I created a character array. So stack of size 100, max is substituted by 100, you know that. As usual, top of the stack is initialized to -1. So let me explain you each and every function. So push function. So push is a function in which I am passing each character. So a into b plus c by d, c d, whatever expression we had. So first character a will be given to this push function. So push function, I'll simply push that character to top of the stack. Now you may ask me, sir, how do you know that this is alphabet and you need to push it? Because you first of all you need to check whether the given character is an alphabet, number, or an operator. So we will observe that there is a separate function for checking all those things. So push is a function, whatever comes into that input character, it will be pushed to the top of the stack. And you know very well, whenever I push, first of all I need to increment at the top, so I am using pre-increment here. So instead of writing two statements, I am writing just one statement. Actually, we used to write top equal to top plus 1. Then we copy the character into stack of top. Since it is pre-increment, first top will be incremented, then the value will be assigned. Similarly, when I say pop, I am returning the value instead of printing. Generally, in normal stack program, we print the popped element, but here I am returning it out of the stack and I am again decrementing the top value. Since decrementing should be done at the end, I am using post decrement. So I hope you are following the logic. Now precedence. As I said, if the operator is either plus or minus 1, plus or minus, we return 1 as the precedence, and if it is star or slash, we return 2, and for cap symbol or caret symbol, we return 3. So precedence is a function which I am going to use. So three functions we have seen: push, pop, and precedence. Now coming to the most important function called as infix to postfix. So friends, please observe here. Infix is an array in which my input will come. It's a character array in which we will pass our input, which is the infix expression. Now in this function, I am creating another character array called as postfix. Postfix is another character array and its size is also max, which is 100. So this postfix is an output string or postfix expression which is initially empty. Okay. Now I am running a loop for I equal to 0. I am running a loop on my infix or my input till I reach to backslash 0. It means till I reach end of the string, I need to scan each and every element. Now observe this code carefully. This is the most important function. If first character I equal to 0. Now what I am checking, I am passing this one to isAlnum function. We have discussed about isAlnum. IsAlnum returns me true if the given character is either alphabet or a number. If it is an alphabet or number, it means what? It is an operand and straight away it can be written to the stack. So if isAlnum function returns me true, it means it is either alphabet or number, and straight away I can write it to my output. So that infix of I is copied into postfix expression. And again, J++ means after copying that first character into the first location, I want the second character to come and sit in the second location. So after copying, I am incrementing my J value also, so that next time when new character comes, it should go to the next location, means A followed by B, like that. Now isAlnum we have used. Else if means if it is not, means if isAlnum returns false. If isAlnum condition failed, means it is not an alphabet, not a number. If it is not an alphabet and not a number, then what it could be? It could be obviously an operator. And if it is operator, then I need to check what type of operator it is. So if it is an opening parenthesis, straight away I can push it to the output expression. So I am calling the push function, which we have seen already. Suppose if it is a closing parenthesis, this one, if it is a closing parenthesis, what we have to do, we have to pop all the elements. We have to pop all the elements from the stack till we find an opening parenthesis or the stack becomes empty. So two conditions I need to check: while top not equal to -1 and stack of top is not equal to opening parenthesis, means till I find opening parenthesis, I should continue popping the elements, and popped elements should be returned to output expression or postfix expression. That is the reason in pop function we have used return character. We are returning it. So pop function returns the character which is assigned to postfix expression. So similarly, and finally that opening parenthesis we should remove it. So that's the reason I am writing pop function again, but I am not copying it into my output expression. I hope this is clear to you. We don't want this opening parenthesis to enter into our output expression. The whole idea of conversion of infix to postfix is to eliminate parenthesis, right? So we have seen whether it is operand or not. If it is opening parenthesis, closing parenthesis, we have handled. If all these cases are failed, then it means it's an operator, right? So if it is an operator, what we are doing? While top not equal to -1 and precedence of stack of top is greater than precedence of infix of I. So what do you mean by this? I am applying precedence function on top of the stack. Top of the stack, for example, it contains star. Then what is the precedence of star? Precedence is a function, right? So when I say precedence of stack of top, and stack of top contains, let us say, star. Star means what? Precedence is 2. And precedence of infix of I means in the input expression, let us say I found plus. So if precedence of star is greater than or equal to plus, obviously precedence of star is 2 and plus is 1, 2 greater than or equal to 1. Means when an higher precedence operator is sitting in the stack and a lower precedence operator is trying to enter into the stack, then what should I do? I should pop the top of the stack, append it to the output expression. Then I should push this incoming character to the stack. So this is what we have done in this else condition. So friends, it's very simple. Whatever we have manually done, the infix to postfix conversion process, that process is converted into a code. And finally, when we reach to end of the string, what we have to do, we have to pop all pending elements from the stack and we will write it to the output expression. And once this entire loop is completed, I'll put \0 in the last location of my output expression to represent end of string, and I'm printing it. So that's it. This is a simple infix to postfix conversion. So enter the infix expression %s. I'm taking it as a string and I'm simply calling. So if you look at main, it's very simple. I created a character array. I'm asking user to enter the input and I'm calling infix to postfix function. So in this function, internally it uses alnam function, internally it uses precedence function, internally it will call push and pop functions also. And to print that output, I am not writing a separate function because in that infix to postfix conversion itself, finally we are writing one print statement. So friends, let me run this. I am using a Visual Studio editor. So in Visual Studio, you can directly see the output beneath the editor, code editor. So I need to type GCC followed by name of the program, and for output you should give a file name. So I am giving infix to postfix. This last one is my output file name and -o represents output. So when this program gets executed, it creates the output in this file. So let me run my code. Once the output got generated, you have to run that output file using / name of that output file. Enter infix expression a into b plus, same example I am giving, the one which we have discussed, abc plus *d/. This is the output. So this is how we convert an infix to postfix expression. And what is the process? The process is, first you should know how to convert infix to postfix, the rules you should know. Then for every individual operation you should write a separate function. Hope this program has given you a clear understanding of how to convert an infix expression to postfix. And I recommend you to implement this again from the beginning so that you get a better understanding and confidence of converting and given infix expression into postfix. So I hope this particular session gave you a good learning experience and also clear understanding of infix to postfix conversion as well as implementation using C. Thank you.